Howdy, and welcome to the graphing tutorial for Chem 105 at Carroll Community College. In this video, we're going to take a quick look at how to take data from your chemistry labs, get them into a spreadsheet program, and then graph them to get the results you need for your experiment. So for this video, we're going to be looking at Microsoft Excel. The reason for that is that every student at Carroll Community has automatic free access to the entire Microsoft Office suite of products, including Excel. There are other graphing programs you could use, but because this one's free and because this one does so much so well, we're going to strongly recommend you use this one. Also, please note I am using the desktop version of the application, not the web version. The web version is missing a few features and also requires you to do certain things with how you type the data in, which column comes first, which column comes second, and it doesn't do well if you have to graph multiple things. So the desktop version is our preferred version of that. So that's what we're going to use today. So what I've already done is gone to Appendix E in your lab manual, where there is the graphing information there, and there is a data table provided for this tutorial, and I've gone ahead and copied that and just typed it in. Column A is where I put all the volumes of the liquids, column B is where I put the masses, and then I put the empty cylinder mass down here at the bottom. Go ahead, pause the video here, find that appendix, or just pause it and use this, and go ahead, type in that data just as you see it. Note that we don't put milliliters or grams with the actual numbers. Excel, when it graphs, just wants a pure number. So up here on the heading, that's where we've put the units. We always want to have labels and units for everything so we know what we're looking at, but we got to have numbers by itself. So pause the video here, get that looking right. Okay. At this point then, we want to say, okay, wait a second, something funny happened here. You probably typed in 2.10, that's the first number for volume, but Excel only shows 2.1. And then again down here, 8.20 became 8.2, and then also here, 38.510, they cut off the zero. So how do we fix that? Because in our data on the spreadsheet, we want it to be the actual data we recorded, the actual measurements. And so Excel, by default, says, the zero doesn't change the value, I'm going to cut it off. We have to tell it to keep those in there for sig fig and measurement purposes. So we're going to highlight our volume data, because that's our first set. This data comes from an experiment we'll do very early in the semester, probably the first experiment. And so you'll be using graduated cylinders that you can read to 2 decimal points. So we want all of these to show those 2. So we'll highlight that data, we'll right click, and we'll go ahead and down to Format Cells here near the bottom. And then we can see, okay, we got a bunch of options. We want to be on the number tab. And right now it's set for general. There's no general format, just cuts off zeros. We want to tell it that no, this is a number and it needs to have 2 decimal places. So it defaulted to that, but we can make sure it's 2 for everything. When we hit OK, all right, now everything has 2 decimal places. Our zeros came back. We'll do the same exact thing for the masses. We want them all to have 3 decimal places. So we highlight the numbers, right click, Format Cells, go here, number, 3 decimal places this time, hit OK, and now we get that 0 back. So that's the first thing. If you're ever typing your numbers in and it starts cutting off zeros, go ahead and tell it, nope, that 0 needs to be there by changing how many decimal places should be displayed. All right, now that we've got our numbers in and they're all set, everything's looking good, we're ready to make our graph. Pretty much every graph that we make in Chem 105 is going to be an XY scatter graph, or a scatter plot. That's where we say we have 2 sets of data, in this case volume and mass, and we want to see the relationship between them. And so we'll say, okay, I'm not going to highlight any data. If you do, Excel will try to guess at what you want to do with it, but it's often wrong. So I just click into a blank spot. I'll go to Insert at the top here on the ribbon. We want to go over here to Charts, click here on the scatter one, the one with just dots, and then we usually want that one, the one that's just dots. And notice how it says scatter. This chart is used to compare 2 sets of values or pairs of data and show relationships. That's what we want. So we click the one without any lines on it, and we just get a blank space. Another way of doing that is to right click and tell it to insert one, but that's probably the easiest way, is go up here to the menu. Now we have to tell it to select our data. So I clicked on the graph, and now two ways again. I can right click and hit select data, or up at the top there's the big select data button. So I'll hit that one this time, and we'll get this, and it tells okay, select data source, there's a range, but it's just saying add a series. If you had highlighted data ahead of time, this might have stuff in it. If it's wrong, you just tell it to remove them. But in this case, we want to add a series. A series is a set of data that we're going to be plotting. All right, so we hit add, and now we get our pop-up that says, okay, we need a name, we need X values, we need Y values. Well, for the name, we'll call it trial 1. There's only one trial in this lab. But in other labs or in other classes, you might be graphing 2, 3, or 4 sets of data all together to compare them. So this is where you'd say, oh, this is trial 1, this is trial 2, trial 3. You do them one at a time. We go to X values. We want to say, okay, what's on the X? In this lab, that's the independent variable. We were measuring or adding volume and seeing what the mass would be. So volume was our independent variable. So I click where it says X values. I then click on just the numbers for the volume, highlight all of them, and it puts them in there. So it says A2 to A9. Yep, A2 to A9 is right. Then for Y values, this one can be a little tricky. Some versions of Excel, you have to delete this one, but leave the equal sign, and then click and drag the cells. For others, you can just delete the whole thing, click and drag, and it works. So mine works. Sometimes they don't, but we'll go with that, and we'll hit OK. All right, and then we'll hit OK again, and you see, yep, we have a nice graph there that is showing a relationship. I see that it's a mostly straight line. That's a pretty good result. That means our data probably are pretty good. So there's a graph of data, but we're not done yet. If you look again back in Appendix E, it tells us that a good graph for science should have a few features to it. So we'll just go back and highlight that. Number one, it needs a good title, that a reader who maybe didn't do the experiment can look at your graph and have an idea of what am I looking at. It needs to have labels and units so that these numbers on the side actually mean something. It needs to have a scale that the size of the graph, that it's not too zoomed in or too zoomed out, that it's an appropriate scale. We need a series key, a label, to tell us what are we looking at, especially if we have more than one set of data on the same graph. We need to know how do we tell trial 1 apart from trial 2. And it needs to have maybe a trend line. If we're looking for a math equation to relate the two sets of data, we need that trend line with equation to tell us what is the relationship, what's the slope, what's the intercept, all that fun stuff. And so if we look at this, we say, okay, yeah, there's a title, but it just says trial 1. If I look at this and I see trial 1, that doesn't tell me anything. I need to rename this something that will make sense to a reader who didn't do the experiment. So I'm going to say this one is the relationship between mass and volume of an unknown liquid. This is from experiment 1, and that is exactly what this is. We take an unknown liquid, we measure its volume a bunch of different times, we measure the mass for each of those volumes, and we're finding the relationship between those two things. So that's a title where now if I look at that, oh, okay, yeah, one of these is mass, one of these is volume, and the graph will give me the relationship. All right, but that now leads us to the second required thing, units and labels. Which one is mass, which one is volume? And so that we need to add in some chart elements. To do that, it's usually easiest to go, again, when you're clicking on the graph, go back up to the ribbon bar all the way on the left. Add chart element. And we can tell it axis titles. We want one for the horizontal, and we want one for the vertical. And you'd see it puts in little placeholders where it just says axis title. It also automatically adjusted the size of the graph for us. You can also sometimes go to quick layout, and you can see this has lots of different ones, but a lot of them have extra stuff that we don't need. So it's usually easiest just put them in for what you need. All right, so let's go to those titles. On the X, remember that's where we put the independent variable. In this case, that is going to be the volume. So we'll say, oh, this was the volume of the liquid. And again, we need to tell the reader what unit was this measured in. And so that's why we put it on our data sheet. This was in milliliters, and we put it again there to let the reader know. So it shows up there. Then for the X, we click here. You don't always get all the way to the top, so you hit delete. Sideways can be a little tricky. This one was the mass of the liquid and cylinder. Because remember, because it was the liquid in the cylinder. You could maybe do it that way. Mass of the liquid in the cylinder. But again, that was measured in grams. And so we've got that. So now when the reader sees this, okay, I'm looking at this relationship between mass and volume. There's where the mass is. There's the volume. Okay, there's my relationship. I see what I'm looking at. All right. The next thing we're looking at is scale. When we look at a graph, we want it to be appropriately scaled so that the data are easily seen. We want it to be where we're not skewing the data, where we're not misleading the reader. What often happens there is people say, hey, there's lots of empty white space here underneath my data points. Why don't I start the graph at like 25 or 30 on the Y? And you can do that, and it won't change the trend line. It won't change anything, but it does sometimes lead to the reader thinking, oh, this is a massive increase or a massive decrease or very large fluctuations up and down, when really, no, you just zoomed in too much. So the rule for chemistry is we leave the zero there. We don't suppress the zero. We show them all the way to 0, 0, unless there's some really good compelling reason not to. And in this one, even though we've got some white space down here, no, we want to see where the zero mass is. We want to see where zero volume is. We leave the zeros there unless the scale is so far off that we're like, no, we can leave it off for some other reason. All right, but we'll leave that there. This is scaled. Excel usually does a pretty good job of that. We will come back at the end of this tutorial. There's a lab later in the semester where we do need to adjust that scale. But for right now, we're doing good. All right. The next thing is a series key. Now in this particular graph, we would not need one. We only have one trial of data. We have one row of data points. So we say it's a relationship, and there it is. We're good. But if we had to graph 2 or 3 or 4 trials, and we wanted to put them all in the same plot, but say, okay, here's what each one is, we would again go to Add Chart Element, and we would go to Legend. And we'd say, do we want it on the right? You can see where trial 1 pops up. Put it up top, on the left, on the bottom. Usually the right is the default. So this would tell us, okay, yep, trial 1 are the blue circles. If there was a trial 2, maybe that would be red squares. Maybe trial 3 would be green triangles, and it would label them for us. And that's where, okay, that's why we said the series was called trial 1. That's what will pop up on the legend. But again, if you only have one set of data, then you don't need the key because it's by definition that data. So we can just click on that and delete it, and the graph goes back like we had it. But that's how you would put it in if you need it. And then the last thing that we won't need for every graph we do, but for many of them, is to add in a trend line. So the two ways to do that, again, we can go to Add Chart Element, add a trend line, and hit Linear. Or we can right-click on a data point and tell it to add a trend line. Either way will work. If you right-click elsewhere, the add trend line doesn't appear. You have to click on a dot to get it. So again, it might be easier. Add chart element, trend line, linear. We always want a straight line, trend line. And it just pops up. You're like, great. What do I do with that? We can then click on that trend line. You can double click it. You can right click and hit Format Trend Line. Either way, you'll get this pop up on the side. And it looks like this, whether you're using Windows or Mac, it looks very similar. The two options that you pretty much always want to click are at the very bottom. we want to display the equation on the chart, and we want to display the r squared value. All right, and then you can X out of this. And then the general rule is, okay, yeah, it usually pops right in the middle and it's on the data and it's hard to read. So you'll click on that and move it where you can see it. Sometimes up top is easiest, sometimes down here in the bottom. But find an empty spot on your graph and go ahead and move that so you can read it clearly. And again, I as your professor or whoever's reading it can see it clearly as well. All right, but there's your trend line. The equation gives us the actual relationship. That's a y equals mx plus b equation, where we'd say we have y equals m, so that 1.0189, that's the slope of this trend line. And yep, it is increasing, so it should be greater than 1. And then the 32.267, that's our y-intercept, that's the b. And in the case of this lab, you'd be looking to say, hey, does that 32.267, that should be the empty cylinder when there's 0 volume. How well does that match up to my 32.118? You say, okay, it's pretty close, but it is off by a little bit. That's one way you can tell how your data collection went. The fact that those two numbers aren't the same tells us, oh, maybe these volumes we were reading, we weren't quite right. Maybe we weren't quite reading the very bottom of the meniscus. Maybe we were estimating a little bit wrong. But that intercept can often be a little correction factor to say, okay, I was off a little bit. I can try to do better next time. It'll let you know if something major happened. All right? The other feature, the r squared, we put that in there. That is known as a correlation coefficient. The maximum value for r squared is 1. If your data form a perfect straight line, then r squared will equal 1. Where everything, yep, it's perfectly on that line. If you don't, if something's a little bit too high, a little bit too low, that's where it starts decreasing. Well, here on r squared of 0.9996, that's a very good line. That's a very straight line. That would again give you confidence that yes, I did my data collection well, or if there was an error, like we saw, okay, the intercept's a little bit off, at least we made the very same error every single time so that everything's off by that same little bit because my r squared is still good. So everything lines up. So you want to put that in there. Those two numbers will let you know where the error might be. If the intercept is off, okay, you did something wrong, but you did something wrong every time. If your r squared is off, okay, some of them way too high, some of them way too low. Yeah, you're messing up somewhere in there. You're not being consistent. You need to do better with your data collection. All right, and we put that up where we can see it. And at this point, this graph is done. This graph is good. If a student of mine turned this in, they'd get full credit for this graph. Everything I need to see is on this graph. All right. I did mention that in one lab much later in the semester, you'll need to adjust the scale. So I do want to show you how to do that. And you'll actually be adjusting it with the trend line, so it's easier to do it here with that. Just right-click on the trend line format, or again, double-click, and we can do this forecast. The idea being that in some cases we want to say, hey, with data collection, we had to stop here because we ran out of room, we ran out of chemical, ran out of temperature before something happened, but let's see what would happen if we kept going. Or the backwards forecast, okay, in the case of the lab we will use this for, we try to get things colder and colder, but there's only so cold we can get. And we want to see, well, no, what would keep happening if we could go even colder? So I'll do that one. When it says periods here, they just mean whatever this x value is. So here, I'm around 2. If I want to say, take this line down to about -5, well, I'm here right around 2. I need to go 7 and more in that direction to get to -5. I'll just tell it, oh, go back 7 periods, and then click out, click back. Yeah, and there it goes. Now it went back to -5. Okay, let's get rid of that now because it doesn't look good. Go back to 0. Okay. But for this tutorial, that's how you would do that if you need to go forward or backwards with the trend line to predict something. But again, the equation could also let you know, oh, if I need the value when x is -5, let me plug in -5 and then see what do I get for y. All right? But this is the end of the 105 graphing tutorial. There are many more advanced features that Excel can do, but this is where we need you to be for Chem 105. If you have questions, please see me during office hours, see the tutors in the Academic Services Center, or ask your instructor for additional help. But I hope this was useful to you, and good luck in chemistry class this semester.